Okay, class, welcome back. This is section 4.5, or the subject matter of solving systems of linear inequalities. Okay, we have already graphed linear inequalities, one linear inequality. So if you want to go into a little bit further or in-depth review on how to graph a linear inequality, you can watch video 3.7. So I recommend watching that if you're having a hard time following these steps or understanding any of these concepts. Okay. Otherwise, this should be largely review. So our steps for graphing systems, first of all, some asterisks. We need to remember a few things. We need to remember that if I have an equal to sign, then the line is going to be solid. And what that means is that points on the line make the statement true. So if I had x is greater than or equal to 1, say, and I were graphing this, and my equation looked like this, and I wanted to plug in the point 0, 1. The point 0, 1. Excuse me, the point 1, 0. The point 1, 0. So this point right here, the point 1, 0. So this point that lies on the line, then I would say 1 is greater than or equal to 1. You can see that this is the equal to part of the statement, and it's true. So if I plug in a point that is on this line, it's true. So the way that I show that graphically is by making it solid. Say, hey, everything on this line is a solution too. But what about the point 2, 2? Let's plug in the point 2, 2. Okay, well, there's no place to plug in a y, so I'm just going to plug in 2 is greater than or equal to 1. Well, this is also true. So that means all of the points over here where 2, 2 would be, which is right here, are true. And also means that points on the other side, so let's plug in the point 0, 0. If I plug in 0 for x, 0 is greater than or equal to 1. This is false. So if the point is false, which is, this is the point I just plugged in, if this point is false and it's on the other side, then all of this over here is false. So the way that we say, hey, this is all the true stuff, is we shade it. Okay, so we've got a dividing line, and either the dividing line is included or it's not. It's included when there's an equal to part of the statement, and it's not included when there's not, because points on the line make the equal to part of the statement true. Okay, so again, for further review, you can check out video 3.7 on graphing linear inequalities. Okay, so our first step then to solve a system is just to graph. So this first step here is just to graph these lines. When you graph these lines, you don't need to worry about what the inequality says, because where the line is doesn't change based on the inequality. Okay, remember that we have three methods for graphing. We can point plot, we can put in slope-intercept form, or we can find the intercepts. Well, this problem right here is already in slope-intercept form, although it kind of looks backwards, but it says, if I flipped it around, that y is less than a negative 2x. So this is my line 1. I'm going to do this in blue. Again, if negative 2x is greater than y, then y is less than negative 2x. This has no mx plus b, this has no b. So that means that this line goes through the point 0, 0. Okay, and that would be this point right here. From there, my slope is negative 2 over 1. This means I'm going to go down 2 and right 1 from the you are here point, which happens to be 0, 0. So I'm going to go down 2 and right 1. You'll note that this line will be slanting downward from left to right. Try to draw a really pretty graph here. Woo-wee. Well, other than my line being a snake instead of a line, there we go. Not too bad. All right, this is what my line would look like. Okay, so that is my first line. I used slope-intercept form to graph this. My second line is not in slope-intercept form, so I am going to put it in slope-intercept form. So line 2, I want to graph it using slope-intercept form. So right now it says this, and I'm going to just change this to an equal to. I know it's not equal to, but where the line is doesn't change. So I'm going to subtract x. I'm going to get 2y is equal to negative x plus 3. When I divide by the 2, then we get that y is equal to a negative 1/2 x plus 3/2. This means that the u r here point where we're starting is at the point 0 and 3/2, and my slope is negative 1/2. This means I'm going to go down 1 for every right 2 that I go. Okay, so you are here. 0 and 3/2 is this point right here. That's 1.5. And from here I'm going to go down 1 and write 1, 2. Down 1 and write 1, 2. Up 1 and write 1, 2. Okay, so this line then is going to look like this. All right, so the steps here, I'm going to do this for each line. So for line 1, I have graphed line 1. Now I have to decide whether it's solid or dotted. Well, line 1 has a less than with no equal to, so this line should be dotted. That again means that points on this line will make the statement false. So if I plugged in a point that was on this line, this original statement right here would be false. Okay, this one also has a no equal to, so this green line is going to be dotted as well. Okay, and now I just need to choose a test point. Whenever you choose a test point, you want to plug it into the original. Since we graphed this using equal to, we want to plug everything in to the original. So I'm just going to choose a point that is not on the line. So for the blue line, the point 1, 1 is not on the line. So I'm going to plug in, so this is my test here, and see. I'm going to plug in the point 1, 1. So when x is 1 and y is 1, is this a true statement? Is negative 2 greater than 1? It's not. This is a false statement. Negative 2 is less than. So since 1, 1 is this point right here, if this is false on this side of the blue line, then I should be shading over here, all of this area here. So this is all the true region. All right, so I've gone through steps 1, 2, 3 for the blue line. Now we need to do step 3 for the green line. For the green line, I'm going to plug in the point 0, 0 because it's not on the line. So my test for the green line is going to be the point 0, 0. That's always the easiest as long as it's not on the line. I couldn't use it for the blue line because it was on the blue line and I already know that that would make it false. Okay, so plug in 0, 0 into the green line. So I'm going to get 0 plus a 2 times 0 is less than 3. 0 is less than 3. Well, this is a true statement. So 0, 0 is on the bottom side of this line, so we would shade all of this area for the green one. So the only difference here between 3.7 and graphing just a single inequality versus graphing 2 inequalities is that you want to make sure that the solution is where all are true. So this area right here, in between here, only the blue is true. From here down to here, the blue and the green are true, and from here to here, only the green is true. So I want to make sure that when I shade this, I am only shading this region here. Okay, and not anywhere inside of here, or on that side. Okay, so this is where they overlap, so where they're both true. Remember, to solve a system, it's what makes both of those statements true. Okay, so that is our example 1. So for example 2, instead of graphing 2 systems, we're going to graph 3. It's a really nice I'm going to write this up here and give you a chance to write on it. So with this system, this is how they're written. We've got 3x minus a 4y is greater than or equal to a negative 6. We get 2x plus y is less than 7. And a third line, y is greater than negative 3. So this is our system, and we want to graph these. So let's put this graph over here. And you can go ahead while I'm doing this and start figuring out what method is going to be best to graph these inequalities, each one. Okay, for the first one, I think it's going to be easiest to put all of them in slope-intercept form. So for line 1, which again I'm going to graph in blue, I'm just going to put it in slope-intercept form. So line 1, I'm going to say 3x minus 4y, and I'm just going to change this to an equal to because I can. That sign doesn't matter. Only matters when I'm determining where to shade, and because we plug that into an original, we'll account for that sign. So we'll get that a negative 4y is equal to a negative 3x minus 6 divided by a negative 4, and we get that y is equal to 3/4 x plus 3/2. Okay, so step 1 is to graph this line. Well, this is the point 0 and 3/2. Hey, that's where we were before, so point 0 and 3/2. That's 1.5. From here, I'm going to go up 3. 1, 2, 3, and right 1, 2, 3, 4. Okay, which is the same thing as down 1, 2, 3, and back 1, 2, 3, 4. All right, so my blue line is going to look like this. That might be one of the best lines I've ever drawn. Okay, so I've graphed my blue line. The second thing I'm going to do with the blue line, for each line I'm going to go through all these steps. The second thing I'm going to do is I'm going to say, is this line solid or dotted? Well, because the blue line has an equal to, then this line is going to be solid. So I'm going to leave it solid. And now I want to choose a test point for the blue line. So we'll do just the blue all at one time. For the blue line, 0, 0 doesn't lie on that line, so I'm going to plug in the point 0, 0 for my test. And again, I'm plugging it into the original, not into this equation here, because I changed this to an equal to and didn't follow any other rules of inequalities, so I'm just going to plug it into the original. So I'm going to get a 3 times 0 for my x minus a 4 times y, or 0 for my y, is greater than or equal to a negative 6. Well, that just says that 0 is greater than or equal to negative 6. 0 is indeed greater than or equal to negative 6, so this is true. So all the points on this side where it's true should be shaded. So for this line, I would be shading this underside. Okay, so that is my line 1. I'm going to go ahead and erase this work for line 1, and we're going to work on line 2. Line 2 is going to be 2x plus y is equal to 7. Again, I'm just not going to worry about the inequality because we plug our test point into the original. So I get that y is equal to a negative 2x plus 7. All right, so my u right here point is 0, 7. That is at 1, 2, 3, 4, 5, 6, 7. And this is also slanting downwards, so my slope is going to be negative 2 over 1, so that's going to be down 2 for every right 1 that I go. So I'm going to go down 1, 2, right 1, down 1, 2, right 1, and down 1, 2, and right 1, just so I can have several points here. And that line is going to look like this. These almost look like they are perpendicular lines, but it doesn't matter whether they are or not. All right, so for the second step, I'm going to say, is this line solid or dotted? Looking right here, that is dotted because points on the line, if I were to plug in a point that lied on this line, then it would make this statement right here false. Okay, so the line is going to be dotted, and that's visually how we represent that. Now I'm going to plug in a point not on the line. Again, 0, 0 is always going to be that easiest point, so my test point for this line I'm going to choose is 0, 0. And I'm plugging that into the original. So 2 times x, which is 0, plus y, which is 0, is less than 7. Well, 0 is less than 7. This is indeed true. So we've got true here. 0 is less than 7. So that means that I'm talking about all the points on this side of the green line. So I'm talking about here, okay, everything on this side of the green line. All right, what about our third line? Our third line is already in this slope intercept form. It says that y is equal to -3. Remember that y equals any number is a horizontal line. Y is always -3. Well, it's -3 right here, it's -3 right here, it's -3 all along here. Okay, so this is my y is -3 line. But this sign here says that points on this line are not included in this solution. Okay, so I've got to make this line dotted. So there we go, we have a dotted red line. Now I'm going to test my red line to see where I should be shading. So again, this point 0, 0 is not on the red line, so I'm going to plug in 0, 0 and say, well, there's no place to plug in the x, so I'm just going to plug in the y. Y is greater than a -3, okay? Into the original, 0 is greater than -3. That is true. So I would be shading everything above here. Okay, well, all I care about is where they overlap, which is all of this area in here. So I would not shade here, here, or here. I would only shade this area right here. Okay, so this is what's shaded. All right, so this is a compound inequality. And let's do one more example. All right, so we will do, that's really pretty. I did a good job. You know? All right. This time we're going to do a system of 4. You won't have any more than 4, so this one is going to be a 3x plus y is less than 4. X is less than or equal to 4. X is greater than or equal to 0. And y is greater than or equal to 0. Okay, so what does this one look like? Well, let's get our graph out here again. That's kind of messed up there. This is our last example in this section, and hopefully this is making sense. If you have any questions, I would love to answer them in class. All right, so my line 1, it's going to take one step to get to slope-intercept form. So we've got 3x plus y is equal to 4. I'm going to subtract the 3x, and y is equal to -3x plus 4. That means that I intersect the y-axis at the point 0, 4. 1, 2, 3, 4. And from there, my slope says that I'm going to go down 3 for every one I go right. So from here, I'm going to go down 1, 2, 3, and right 1. 1, 2, 3, and right 1. So the blue line looks like this. However, this blue line, you can see here, is going to be dotted. That means points on the line won't work. You put it in there, it'll be like, no, that's false. That's our visual representation. So when we look at that, we say, we can't include those points. All right, next line. Oh, test point, here we go. Test point for this line, 0, 0 is not on it, so I'm gonna plug in 0, 0 into this line. So my test point is 0, 0. I'm gonna do 3 times 0 plus 0 is less than 4. 0 is less than 4. Well, yes, it is. Yes, yes. So I will be shading everything on this side of the blue line. Because 0, 0 is on this side, everything on this side would make this line and this inequality, original inequality, true. All right, so x is less than or equal to 4. And I wrote a 1 there, I meant to write a 2. So equation 2, x is less than or equal to 4. Well, any equation that has x is equal to some number, whatever it is going to be a vertical line. So it's going to be a vertical line at x equals 4. So that's 1, 2, 3, 4. So everywhere x is 4, like here and down here and all over. It's all 4 everywhere. And I swear someday I'm going to learn how to draw a straight line. Okay, and it says here that this is less than or equal to, so this line is going to be solid. And x is all the points that are less than 4. So 0, 0 is not on this line. So I'm going to plug in the point 0, 0. There's no place to put this y, but the x is 0 is less than or equal to 4. This is true. So I'm shading everything on this side of that green line. Okay, so what about x is greater than or equal to 0? I'm going to represent this third equation with a red arrow. That is this line. That is the x-axis, okay, that we're talking about, and it is indeed solid, so we're going to leave it solid. So that is just, wow, that's this line here. And I'm also going to write y is greater than or equal to 0 here. But first, let's figure out where x is greater than 0. If I plug in the point 3 for line 3, if I plug in the point, let's plug in the point 3, 3. Well, there is no y, so I can't plug that in, but 3 is greater than or equal to 0. That's true. The point 3, 3 is over here, so for the red, I'm shading everything on this side. Okay, and for the y is also greater than or equal to 0, so I'm talking about the y-axis. Y is 0 right here. It's going to be solid for the same reason the x is solid. And y is greater than, so I'm going to plug in that point 3, 3 again, but this time it's going to be the value for y, so 3 is greater than or equal to 0, and that is true. So I'm talking about all of the values up here. And the question is, where on earth do all of these overlap? And it happens to be this teeny tiny area right here, because we're greater than x, we're greater than y, we're to this side of the green line and to this side of the blue line. So none of this matters anymore. Okay, so this is the solution here. Just that little tiny area is shaded. All right, so this is the end of 4.5 video, and hopefully a good review.